Hello and welcome back to another episode of Getting into Git-Oxide. Hello and welcome back, Sid.
Hi.
Today, finally, after all these days of digressing into other things, we're back to what we originally came for, which is describe, git-describe.
Exactly.
And I think last time we already created a little test that is failing if I would execute that. So now it's really about understanding what this is supposed to be and having some sort of test case here that we can use to get the first expectations going, and then we can probably build it backwards using TDD. And I don't really know what I'm doing, and usually I'm afraid of that, but that's the beauty of TDD. You can really just work backwards, and then you learn what you want to do by trying, so to say. And the more test cases you have, the more you force yourself to spec out what you want to do, and eventually just put some code there that does it, right? Easy.
Exactly.
Let's see.
Setting some goals and then trying to reach them.
Yeah, it's interesting. Like putting some flags down and say, okay, you got to go through all of these. Do something that does it. Okay, fine. Then let's run this.
So I guess we start with the most the name already says it, the most simple version, right? The commit, which is already a tag object.
It names the ref after the tag the described commit is on. No, wait. What is this supposed to be? It names the ref the described commit is on. Or maybe it uses the ref the described commit is on. I think it wants to say if our commit to describe is directly on a tag or ref that is included in the set of names, then just name that, and that's it.
Exactly. So no lookup, no traversal at all happening, basically.
Yes. So that to implement that should be quite trivial. And probably that's the reason why I chose that first. And here it says not found because that make repo sh is not there. For orientation, we are in the new Git revision crate, which deals with revision names and specifications and parsing that stuff back, because it always is two-way, huh? What you get from the git-describe, you can parse with git ref parse. And there's more ways of describing a revision as well, using name ref, for instance, and all that kind of functionality about names of revisions is going to go in here. That's the plan. This is why we have a mod describe, because that deals with the describe functionality itself. Yeah, and then about the test case, we already have a crate that is called git traverse. And that deals with the traversal of trees, but also commit graphs. So here we can traverse the ancestry of a commit, and it has a few options to, deal with the way it's sorted, topological sort or sort by date, topo plus date essentially, and how to deal with parents and so on. Maybe we can use that traversal, but independently of that, there are tests here that obviously have some sort of branching, create a history with branches and so on. And we can probably just use that to get to most of the things we want and then extend it as needed. So traversal, make traversal repo for commits with date, commits for trees. So maybe this one here. Can just take this and then go back to the revision test here. New package, something you really have to learn. Package is a directory because it's still Java speak here, because it's IntelliJ. And I want a new package, thank you. It's called fixtures. And I think then in there I just have the plain. God, why do I not have a memory anymore? Yes, okay. it's just directly in fixtures. Makes sense. So yeah, we can just call it make describe repo or something, because we use it for that. Okay, so make repo with branches. Maybe
this will be the branch. Okay.
Something like that, because you might reuse it for other places as well. Just something with a more complex history. Okay. Then it's called make repo with branches. So this Git test tools here, it has a bunch of assumptions about where to find these scripts. This is why I have to put it to fixtures, because it looks and tests fixtures for these names. And just by convention, you know, to keep it standardized and simple. And now if you run it, we should already work. And let's also have a look at this, just to see what this is building more visually. I think would help. Git revision, tests, fixtures. Then it creates this generated do not edit, and then there's some hash. It's a GiG-32 of the script itself that it executed. So whenever you change the script, it will just create a new folder, but it will reuse the contents of this folder if the script doesn't change. So it's a caching mechanism, essentially. It executes the script once. And that really speeds things up and allows you to have scripts that run 10 seconds, for example, to build big repositories. And then you just reuse that, which I do, of course, everywhere. And it's fun. Like I build a repository that takes like 10 or 15 seconds to build on Mac OS or on Linux. But on Windows, it takes 2 minutes to build, because executing the git command, you know, executing programs on an operating system like Windows is a very complicated thing and takes a long time. So these git invocations, they really cost you. So there's repo here. And I think we should be able to use that, huh? I can imagine.
Yeah.
Git-describe main. Oh yeah, I have to give, oh right. Now we have to figure out, I mean, what we could do is to try to use git-describe here, which needs names, huh? And we can place some names in the right location so that we can use git-describe accordingly and try it as well. Like git-describe, we also want branches, so that we can try it right here. So that describes head, and that's currently main. That makes sense. Head, and then we go into the second part of the branch. Look, we now went into the second parent. So we land on this branch. And now it should probably have trouble. So now from there we go one back. And now we have trouble describing it because there's no text in the history of that. So on C1, we could create a tag. So we have some baseline name here for the initial commit. And then we have a bunch of commits here for a simple linear history maybe, where we can try some describe operations on. And then I would also like to have some sort of name that points to that allows us to see that it counts commits on both branches. How does that work? How does that work again? Right, if C4 would have something?
I think it's already for branch 1, where the branch 1 tag is basically. That should already count the left side as well.
But we have nothing, like if I tell it to describe B1, C1, it already fails because it looks for something in the past to exist.
Yeah.
Yeah, let's just put some names down. So git tag first, and you go on to this one. Okay, so now there's some baseline here for the describe. Okay, so if I ask it to describe this one, 9152, here's this one I was pointing at with this. 9152, it tells us it's 4 in the future. And we are 1 from the first. So we are 1, 2, 3. Whew, interesting. I would already have trouble notice or understanding why it's 4 in the future from first. Like this one here, huh? Ah, no, wait, I miscount that. 1, 2, 3, 4. Because this one is on the left side. Okay.
It's part of the left branch. Okay.
That makes sense. I mean, if it can follow. Okay, maybe, I don't know. I mean, obviously it does it like this. Probably it makes sense. But this is one case we definitely want. So we can just use first here. So after we create it first, we can say git tag first, and that will give us the initial commit. Of course, we can also refer to commits by, for our implementation, we don't necessarily need real tags or real branches, because I would lean towards just giving it a map of names associated with the commit hash. And then you can just do whatever, the caller can do whatever, because we are plumbing. We don't have to be the scribe on a high level. We don't have to program the CLI. You just make the CLI possible and that helps understanding the CLI as well, because ultimately I think it just boils down to a bunch of, lookup table here and a graph there, and then there you go. And there's not too much more about that, probably. Okay, now, how do I get this other case where it counts the left side as well? Should I put down one here, maybe? Would that then count both sides? Probably not. Ah, right. Remember when we had git name or git namespace or something, like one of my create a git temp file. I think it was here on the right side, and then it counted both. So if I would put one here, and then it should give me, and then ask it to describe this one, maybe it gives me 2 then. Maybe. Let's try, huh? Let's try. Git tag. Second. So I would put one down here. And then we have another name. Git-describe. Just look at tags. Yeah, might as well graph it again. Git-describe tags. And what happens now? Second 1. Okay, so it really just goes 1 to the future. And not 2. I thought it might count this one as well, but it does not.
But the point that you're looking from is in the same branch as the tag, right? So I think for me that makes sense that it would only stay there.
So theoretically, if I look for this one, it should give me 2, maybe?
I'd say 3.
Think again. So wait, the head is this one. Let's be sure. 01 EC18A. Okay. I mean, that's interesting. We can just take it like this and say we expect exactly that when we do our testing. So how do we get there? Second plus 7. So 1, 2, 3, 4, 5, 6, 7.
Counts all of them.
Counts all of them. And I don't know what the abort condition is. I thought it always stops at the common ancestor, but it does not, apparently. It's good that we have this case here, because otherwise we might just make something that makes it stop here. It really is insane, isn't it? Like, it's super unintuitive, that thing.
It really is.
I mean, for me, probably you have to, I don't know, there's some piece of knowledge missing that would make it super intuitive and obvious, but I don't know what it is. Okay, anyway, that's great. That's 3 test cases already that we can try to reproduce. First, second, we put on 9.1e, so that is B1C1. So right after this one, we should be able to put this tag down. I don't know, is there better names for this? At C1, maybe that. It's at C1, it is at B1C1. Okay, a bit more descriptive, probably will help. Yeah, and I mean, this is already the case that we want, and it's kind of even a special case because it goes beyond that common ancestor. And let's put another one down here at this one and see how that makes things work. Git tag third. So if I describe the same one again, now it goes third 3. Look at that. Third is here. And now we count 1, 2, 3. So now it stops here. Okay. You know, maybe this thing just does kind of a stupid search. Maybe it just searches for tags on all sides of the tree, of the traversal. Maybe it does just a topo search. Okay, I go down here, count. 1 to get 7. So how do I get 7? I count down here, 1, 2, and I found a name. Cool. But I have the other side too. So 1, 2, 3, 4, 5, and now this stops here. And I think it's just a topological traversal where it stops when it found the name for each parent of a merge, for instance. And then it can stop searching and it will collect the sum of all the intermediate commits. That
makes a lot of sense, because if you start searching the left branch first, you wouldn't stop at the branching point because the tag could still be below it. So you search until you find a tag, and if it's not the right one, then you count the other branch as well, because it could be in there, or it's the other way around. But you have to search until you find a tag, and you do that for every branch, basically.
Yes. And then you choose the name that is closest to you, but you choose the number that is the total of all the commits that you've seen so far. So that's that, I guess.
This is still super unintuitive, but because what exactly does this number then tell me? Like, why is this 7? This really doesn't make sense at all.
Yeah.
I mean, I understand it from like
Yeah.
why the algorithm says 7, but just that number doesn't tell me anything in this context. Like, it's not really useful.
Yeah.
But
Yeah.
maybe it doesn't matter. It's just to describe, to give it a unique name.
Yeah. The problem is it degenerates information. Like this 7 is made out of 2 and 5. And 2 from the second one and 5 from the other name that we don't even see. And this makes it useless, kind of, because you will count up from here. And you just can't. Like, you know, if you generate one of these, I think the parsing, if you want to parse this back, just means ignore, use. Because why would I use anything else? Like, the name is interesting, but the number will probably not help. So I have to rely on this. And why would I ever even try to find anything with these two values? Because I know they could be anything and could lead me to somewhere else. Why would I do that if I know that this ultimately is the deciding factor? And only if this is ambiguous somehow, then I would probably have to follow this to know which one it is somehow.
But didn't we already test that this actually disambiguates the short ID as well?
Yes. We will provide a non-ambiguous ID, but over time these could become ambiguous.
Oh.
Like, this is the only thing I can imagine when I would use this to know which one. And that's probably then not ambiguous. Like, if we are really unlucky, then we are still ending up on 2 commits that are the same prefix, and you know, you can use this number to end up at either one of them, and then you still don't know, but it's probably very unlikely. And that's going to be interesting when we look at parsing this back at some point, which probably doesn't need it for working, to learn how Git does it. Does Git actually look at this in case of disambiguation? I would rely on, I would first not implement this. I mean, who has the time to follow this? This is not the fun part either. I find git-describe very, very unfun compared to head. To, you know, this is cool. This is actually description language for a graph, and really concise and precise too. This makes sense to me. I like that. But this, don't know. Okay, cool. But and you know, I wonder if Vergen really knows what they're doing, because they could use git name ref. They could use like the best possible name. They could have a reference in the future and look to the past, or, you know, they kind of they take the past and look into the future with git-describe, which is useful if you're working on a local working tree that doesn't have tags yet, and that is kind of the latest development. That makes sense then. But why constrain yourself to that? And maybe that's also something to look into. Is git-describe also a name ref under the hood? Is it able to, you know, when you do contains here, then you get git name ref essentially. We know that already. And then it has to be in the past. So if I now want to describe 9556057, then I get this kind of syntax. And it could automatically figure this out as well. But I don't know if it does it or not. I don't think it does. Yeah, anyway. It's interesting.
It is what it is.
It is what it is. Okay, we don't make it better. We just make it what it is in Rust. Okay, cool. So now we have a bunch of, is this enough? Having third would probably also be interesting, huh? Then we get 3 here. Because it stops there then. Yeah, it could be interesting. Let's just have more cases. So let's put a third down after C5. Oh, no, wait. After, oh, that's C5. Why am I? Check out main, commit. Oh, yeah, okay. just here, git tag at C5. Okay, cool. Let's run it again. And now we should have exactly what we had before. Works.
Good start.
Good start. And now let's find, maybe whatever we use, as long as we give it a name. We can call it main here. Yeah, we can just do this like that, I think. And I definitely want this into its own module. And what's important is, as long as you have a top level module file, this will be turned into its own test, into its own test suite, if you so will.
Okay.
And as long as, I want revision to be the one entry point here. And then from there, all the tests are run. And in order to do this, you have to make this I have to make this a module directory. I don't know why it goes back and forth, but now it won't be picked up automatically.
Yeah.
So, it has problems. If I do this, then it messes up the module. That's not supposed to be main. That's going to be mod. And now we're back in business. Cool.
Cool.
Yeah. And now all the questions. What's the API going to be? What do we even need for testing? Right now we only have Git test tools. We don't have anything to interact with the repository.
So we would at least need Git revision, or is that's
automatically
included? Yeah.
That we get, we get everything that is part of the normal dependencies. By the way, this should be dev dependencies, not dependencies. That's only for testing, the Git test tools. And the dependencies we don't know yet. But here for accessing a Git repository, we could use objects. We have to traverse a graph. Git traverse answers a similar question already. Because it has to be able to traverse commit graphs, and it does that by knowing about objects and knowing about hashes, so object IDs, it has to know. And it has to be able to access commits, and commits are defined in the Git object crate. So I think we need at least 2. And since we want to have errors, I guess this we need. Yeah. Or we could just use git traverse. But I think right now it's not good enough to do what we needed to do. Because this traversal here, it's... Where is the iterator? Iterator. Impl iterator. Because this just gives us object IDs. So if we specify traversal, for instance, from head, then it will traverse in some shape or form, in some way, and give us object IDs. But we wouldn't know where that is in the graph. We have no idea. We don't know if it's the first parent or the second or something like that. It's a flat list that we see in the traversal that we currently have the answers to traversal. So this is why I'm thinking...
Is that what you specify somehow, how it's being traversed, or is that always predefined?
You specify how it's being traversed, but we wouldn't know about the topology at all. Because we just see object IDs, and to us, it's undistinguishable from a flat list.
Oh, I see. Okay.
So we would have to, like, if we do the traversal, then we would have to read the objects and kind of make our own idea about what's what, but then we basically already could do the traversal ourselves.
Yep.
And the question really is this traversal here too simple? Should we rather try to, like, would there be a way to provide topological information that would allow us to do our job just by using the traverse crate? And if so, that would be helpful, I'd say. That would be really interesting, because then we can just reuse the traversal. But I guess we will see when we see. For now, I would just say we do our own. We can use this to see how that would work. It seems easy enough. Topological sort. Yeah, so there's not so much about traversal here, apparently. And this one here, it does know... It does know the... Yeah, it does know the topology. It sees that, which is really just which parents do we have. Where does it get the parents? Ah, yeah, here. Here it gets the parents. Yeah. I digress by even looking at it because it's not quite the time yet, but I think it's interesting to see that commits to it, like it finds the commit, writes the data into the buffer, gets a commit iterator, and the commit iterator is really iterating over tokens that it parses one by one, because we don't even decode the whole object at once. We just decode the portions of the commit that we want, and then we stop. So just for you to, even though I do digress, but it's interesting, I think. Git cat file pretty head, because you see this is literally what a commit is to Git. It's this file, right? And you parse this file. And this you can skip the tree, but then you just parse all the parents, and the rest you can ignore as well.
Okay. Mm-hmm.
And this is how you save time parsing, because you don't actually parse stuff that you don't need. You just parse what you need. And that's also what Git does, actually. So Git Oxide has to do it too, just to be extra efficient. Same it does for trees, like no allocation, always done lazily on demand and so on. Pretty neat. Okay, but yeah, it doesn't look too painful now that I see it again. I think it's something we can do in some way or form. Okay, then let's copy this. And I think for now it's really the same dependencies. Need git hash, git object, quick error. And then back to the original question. How do we interact with the Git repository? Yeah, what do you suggest? What's the easiest to get information about Git repositories?
Not actually sure what's... I mean, you said you can kind of... No, you would need the repository handle, right? Or somehow attach the handle to these objects to get information.
Well, you can. I mean, that's the easiest. We could just say git repository here and use that. And then you have a lot of stuff. Then it parses config and everything. And the only thing we will ever need for this task is names associated with an object ID. So knowing git ref would be nice. And we need an object database. So knowing git ODB would be nice. And that's that. And Git repository has all of that plus extras.
Okay. And we probably want to exclude that from the testing then to make it more efficient, quicker.
Yeah,
so git ODB and git ref.
I like your thinking. I was thinking the same, and I think if you look at git traverse, you see it done just like that. It uses git ODB only. But also, on a historical note, at the time of git traverse, there was no git repository. So it wasn't usable at all anyway. And thus, there is only that. Now I'd say git repository should be fast enough to be usable in these cases. You shouldn't not use git repository because something isn't the way you want. Git repository should be as lazy and as efficient as it can be. And the only thing that it has to do that we don't really have to do is to read git config files. And that's extra work that git repository has to do to come up properly. And it can't do that lazily. It must know. And that's the only thing, but also it's just reading one file, quite literally. And that's not the issue for us, I think, from today's computers and these tests. And I think if you have a problem with performance, we probably have a problem with lots of tests being initialized all over again, and you reinstantiate the repository and pay the cost for that, for just reading git config files. And if that ever becomes too costly, you probably find other ways around that by just using the same repository multiple times, for example. And
yeah.
I'd want to dog food git repository as much as possible. And thus would choose that here.
Definitely. Makes a lot of sense.
Yeah, but what you said makes perfect sense as well. It's really the first time I have the option to do this, to dog food git repository in tests, and I think I want to try. 015. Default features false. Does that work? Yes. But also, there's this big difference that now, of course, initial compilation of tests will take longer, at least the first time. It's not a problem in our workspace, by the way, because in our workspace, we compile all our crates anyway, and we compile them only once. So that's fine. But for people who run this separately, they have to compile more. But I think we don't optimize for them because most people would have the whole repository anyway.
Yeah,
that's that. Wow, so much consideration goes into which dependencies to take. So much consideration, but I think it has to be done. I think it makes sense. Nothing ever seems simple, you know? But I think the more you think about stuff, the more you see the hidden dependencies. Oh yeah, there comes all the compilation. And there we go, cool.
Wasn't too bad.
Wasn't too bad. On a machine that can check out the Linux kernel in 880 milliseconds, mind you. So it's worse elsewhere. For us, it's okay. Then this is what is this even? That's a directory, which is quite literally a path buff, right? Because it's read only, it can stay there. And then we say git repository open dir. Okay. And now we have access to our repository. Cool. And now we can do stuff. Now for git revision, describe. How do we describe it even? Now the fun part. And what do we have here? We have main. Which is a branch. Yeah, I know. We can just get the head commit, I think, as the commit to describe, I think. Like we need a commit to describe. That's what we know. Commit to describe, right?
So it's not a ref, not an object ID, just a full commit object.
Yeah, I mean that's what it boils down to. Also for Git. And Git, whatever you put here, it's always a commit-ish or a tree-ish. This means it will use the git ref parse machinery to parse this name into whatever you pointed at. So commit is the right. And now we don't have to think about what it is anymore. It's just a repo. That's nice. That works well. And then we have the head. And then we peel to commit in place. I think when using Virgin, we implemented all of these nice things that most people want most of the time, and now we benefit. And that gives us a, oh wow, look at that. It gives us an actual commit object. Phew. Parsed and everything, like fully parsed. So that's an expensive commit comparatively. Here, see, so internally we actually peel to ID in place, but then in order to get a commit, we have to decode the object to actually learn whether or not that ID is a commit, because we don't know that. I think this is why this gives you an object here. But cool. We pay for it because we have to, and it's fast anyway. So here we have a commit. And now we want to give it the ID. Yeah, cool. Yeah, I think it can be a borrow. Let's see. Okay, so what else do we need to answer this question? Like if it's directly on something, we...
Doesn't Git revision also need to have this information about the repository, about the ODB to actually do the traversal?
Yes. I can show how this is done in the commit traversal that exists. Because there's this find function here. And find is defined as fnmud that gets an object ID and a buffer for the data of that object, and it wants to get some commit ref either. And this is how you see the object access directly is completely abstracted away using that closure.
Mm-hmm.
And that's how we don't have to know ODB or how that actually works, and you can do whatever you want. And that's cool, actually, right? That's decoupling of crates, because we don't want to tightly couple them. The only thing we know is, you get a buffer that we allocate for you. We don't use your buffers. We use our own. That's also, by the way, it's a bit of it's an inefficiency. Like not allowing this thing to know the ODB means it has to allocate, means the ODB might have its own buffer, and then you have to copy buffers over to this one so that it's what it expects. And usually I solve this by actually not using the high-level Git repository database handle, which abstracts away the buffer, but I use one level lower, which expects a buffer as a parameter. And then you can pass this one in directly, and it will just work. So that's that. And this is also a beauty of that API design, I think, because it really, you don't have to pay for abstractions if you don't need them or they're in the way, maybe, like they're here. Mm-hmm. And you can just easily work around them, and it's kind of obvious how to do that too. But anyway, okay, so now we need some sort of association of names with object IDs, huh? So this thing here, how does Git know that this tag is at this object or at this commit? So for us, it's just an association. This commit has these names or this name. We probably only allow one name per commit.
But it's the other way around, right? The name points to the commit or to the hash.
That's true. In the data structure, it's the other way around. But we would always look it up from the object ID. Like we see objects and then we want to know if there's some name associated with it. So then give us name for the ID. So we can say, like we are plumbing, we can say, okay, this is what we do. Give us what we want in a format that makes sense for us. And I think we can even say it's supposed to be a hash set. And it should be possible to say something like this. Hex to ID. Oh no, wait. We already have the commit. And that commit has a name. And that name, oh yeah. Now the next fun thing, ownership. How do we expect names? Do we own them or do we borrow them? And both has advantages and disadvantages. And we don't usually know what is best. Like for one, you know, some people, they can't own their stuff because it's temporary. So they only see, you know, you traverse references and then you want to dump stuff and you have to own it in order to be able to do that. And some might have a hash map already or might have some data structure that stores these refs. And they are happy to pass a borrowed version of that. And both are legit, like both use cases. And those who have already a backing for the name, they don't usually want to copy it or clone it just because our API is designed that way. It's more like, you know, for 10 or 100 or 1,000 names, you don't care so much if we own it or not. But for 100,000, which could happen, you know, then it costs you. So owning this is something I wouldn't want. But borrowing it for everybody is also something I won't want or wouldn't want. So how can we have both? So that we don't have to make the decision. But at runtime, somebody can decide.
Oh. No, I'm not actually sure.
So copy on write. Cal borrowed. And then we could say, yeah, this is our name. And these refs, they usually have bytes as names. They don't have a UTF-8 string. So we want to pass a B string here. And yeah, we don't even have B string support yet, but it does come from Git object, I think. So byte slice maybe? Yeah, of course it's very, very unhappy because there's no argument here. Can I change this? Look at that, it's pretty smart. We've got a borrowed object ID that is close, and we've got this, which is nearly what we want. Because actually I was planning to collect that, and that can collect itself directly into a hash map. And if I wanted to tell it this, yeah, collect future. Okay, now it's really, really wrong. Okay, let's go with the first one. That's a better basis. So that's supposed to be git hash OID That's the commit to describe. And here's the name set or something. And that's a hash set, standard collection, hash set. We want to own the object ID. There I just make the decision that these are cheap enough to own. I don't want to deal with cows or anything, but in theory it could be a cow as well. Like this object ID, why not make it this, right?
Yeah.
And that's the same answer here. Like, what do I know where your stuff is stored and whether you can give me that or not? So owning this is always easy and safe. Everybody can do that. And making copies of this is super cheap. It's just 20 bytes or maybe more. But it's not a big deal. Okay. And then we have some lifetime that we don't have to care about, I think. And a B string here as borrowed version of this. And we import that as well. And that's the name set. And we return something. Something that we don't exactly know yet. But yeah, that could be the signature. And let's see if that works. That is happy now. Can I just collect into a hash set with this? No, what's the problem? So hash sets, right? If they're key value pairs essentially, and it usually is possible to collect into a hash set if you have an iterable of these key value pairs. And now it's just a question what the problem is. Maybe SB string is the problem here. Hex to ID we don't use. Byte slice is not used. No method SB string found. I think that's maybe because we need this. Okay. Okay, the method collect exists for a blah blah blah, but its straight bounds were not satisfied. Yeah. Also, we want to own that hash set, but I think that's okay. But theoretically, we don't have to own it. It's okay for us to borrow it. So you can call that multiple times with the same thing.
Mm-hmm.
Yeah. So what I apply here is just the rule of don't own things unless you have to, but don't allocate internally either unless you really have to. So I rather take what I need in the format that I need, and then people can ideally build it relatively easily and optimize calls that way. Okay. Ah yeah, maybe either collect or something? Does it? Oh, not bad. Something happened. Okay. Okay, so now we get an iterator over borrowed objects, over borrowed tuples. See that? But we want a hash set that is borrowed, but owns the tuples. It's a little detail, right? But it's important. And do you know why that is? Do you know why I get, when I iterate here, why do I get a borrowed tuple instead of an owned?
That's what iter does, right? I mean, iter gives you the items as a reference, so you need to write into iter to get the own version.
Easy peasy. Easy peasy. I would probably be confused. If I were you, I would be confused still about that. But you are you, and you totally understood how all this works. So yeah.
I wouldn't say. I mean, you connect the dots. This would be my guess. To say I fully understand why it works the way it works is probably not the case. But yeah, this would be enough.
And now, yeah, I think now we now set into either. And look at this. It still has a problem here because it's still there, this %, right? But into either should mean I own my stuff that's in the iterator. And that is something that I believe is due to this edition 2018. If you would, because that's an inconsistency, clearly. It should be owning this, right? But it can't, because into either works kind of differently for arrays here. But this is fixed in 2021. We might be able to see that. See, so in 2021 edition, we actually get ownership transfer here.
Okay.
And now all we want is to actually borrow that hash set that we get, and then it might even compile. See, okay, great, it compiles. It compiles and runs. But we don't have 2021 yet. I mean, we have it, and it's stable, and I want to use it for that kind of thing. But unfortunately, we can't yet because Virgin forces us to use an older stable compiler that doesn't have 2021 support. Yeah. So whenever there is 2021 in the dependency graph, in your whole dependency graph, you don't work with Virgin. And that's a bit sad. And I already had to lock 1 or 2 dependencies down. Here, byte unit, see? Because in the latest version, it has 2021 support. And then Virgin doesn't work anymore. So yeah. Now we have to just wait longer until we can use the latest features. And I can't wait. But it's also kind of dangerous because who knows? Maybe tomorrow GitOxide wants to integrate with foobar, and foobar has an MSRV of Rust 1.50.
Yeah.
And then you're stuck again. So it's interesting.
That's a weird error to solve, I guess. Which one do you prefer?
Yeah. For now, we prefer maximum compatibility, I suppose. So now we are back to 2018 and have to solve that differently somehow. Yeah. I think the easiest way to do this is just by allocating. And then we can do into either and it will do the right thing. Oh, that's interesting. Ah, yeah, right. We want to borrow. Okay. And now we are where we were before. Cool. The first test is running. And since we're already nearly 1 hour in, you can probably implement this in a way that works. Yeah. But I think it's a longer conversation. Or maybe it's not. Like, what do we expect as a return value? Because, I think it's a bit of a longer conversation.
Yeah.
And now we have the first test case that I think will lead us to that conversation and will lead us to the first implementation, which might just be a lookup in a hash set. For this one to work, that would be enough. And then we can continue with other bits and pieces. And we can even, I think what I see coming is we can even totally skip the actual implementation as long as we have the data structures cleared out or set up. We can then decide how we want to format that. And we can implement the formatting first, because ultimately we want to output exactly what Git outputs for that stuff. And maybe I would do that just to not come and have to do the tricky bits too soon. But yeah, there's always another day with me, apparently. So, but I'm happy with
Always
that.
progress, though.
Yeah, always progress.
Looking forward to it.
Yes. I'm looking forward to it too. I'm happy now the first step is made. And with that, you're clearly on track to just get it done. And we have done more complicated things probably, that were just as, how do you call it, frightening and daunting and frightening. But now we're through the door and we'll deal with it, and it's going to be cool. So just the first start. But with that, I think it's time to say thanks everybody for watching, and goodbye.
Thank you. Bye bye.